In this video, we will practice some basic matrix operations like addition, subtraction, and scalar multiplication, as well as reinforcing some matrix vocabulary. Here we are being prompted for the dimensions of matrix A. The dimensions are always in the form row by column. So matrix A has 3 rows, 1, 2, 3, but only 1 column. So matrix A is a 3 by 1 matrix. That's a column matrix, by the way, vocabulary. By contrast, matrix B is a row matrix. It has 1 row and 3 columns, 1, 2, 3. So matrix B is a 1 by 3 matrix. Matrix C is a square matrix. It is a 2 by 2 matrix because it has 2 rows and 2 columns. Matrix D is also a square matrix. This is a 3 by 3 matrix because it has 3 rows and 3 columns. Matrix E is a 3 by 2 matrix because it has 3 rows and 2 columns. Matrix F is a 2 by 3 matrix because it has 2 rows and 3 columns. Matrix G is also a 2 by 3 matrix, 2 rows, 3 columns. Now let's practice our basic matrix operations. Here at the top, they've given us several matrices to play around with. And first, we're going to find matrix M minus matrix N. And I've recopied them here. And so when you add or subtract matrices, they have to have the same dimensions. So notice that this is a 2 by 3 matrix, and this is also a 2 by 3 matrix. If they did not have the exact same dimensions, this would not be possible. Since they are the same dimensions, we can subtract, and we simply subtract the corresponding elements. So I will do -5 minus 2, so that'll be -7. 9 minus 6 is 3. 2 minus -31, that's the same as 2 plus 31, so that's 33. 11 minus 22, so that's -11. -1 minus 10 is -11, and 3 minus 0 is 3. So this would be the result of M minus N. Okay, now let's do L plus L. Again, I will simply add the corresponding elements. So, of course, 8 plus 8 is 16. 10 plus 10 is 20. -1 plus -1 is -2. -9 plus -9 is -18. 4 plus 4 is 8. And 1 plus 1 is 2. So this would be the result of matrix L plus matrix L. What about matrix K plus matrix L? Well, matrix K is a 2 by 3 matrix, 2 rows, 3 columns, while matrix L is a 3 by 2 matrix, 3 rows, 2 columns. You cannot add or subtract matrices when their dimensions are not the same. So this is simply not possible. What about N minus M minus K? This is going to be possible because all 3 matrices have the same dimensions, 2 by 3. So just work from left to right. So first we will simply find N minus M, and then we'll take the result and subtract K. So forget about K for now, and let's just do N minus M. So I'm not going to do this one by one on camera, but I will be subtracting for example, 2 minus negative 5, and that would be the same thing as 2 plus 5, so that would be 7. But I'll do the rest off camera. So this blue matrix is the result of n minus m, and that gives me this blue matrix. And then we proceed and bring down matrix K. So we need to take the blue matrix that we got from subtracting n minus m, and now we will subtract matrix K. Again, subtracting the corresponding matrices, for example, 7 minus, the corresponding elements. For example, 7 minus 0 is 7. Negative 3 minus negative 3 is the same thing as negative 3 minus, is the same thing as negative 3 plus 3, all right? Minus and negative is addition, so that should be 0, and so on for the rest of the matrix. So this is the final answer for n minus m minus k. You would get this red matrix here. All right, practicing our vocabulary. When we say 5m, this is 5 times matrix m. The number 5 is called a scalar, and this is scalar multiplication. So when you multiply a scalar times a matrix, you simply multiply the scalar times each individual element in the matrix. So I'm going to get negative 25, 45, 10, 55, negative 5, and 15. So that's how you do 5 times matrix M. Well, now we need to find negative k, or sometimes read the opposite of k. Well, negative k, or the opposite of k, is the same thing as negative 1 times k, just like another scalar multiplication. So I'm just going to multiply each element by negative 1. So that's going to give me 0, 3, negative 4, negative 1, and positive 5. Okay, or you could think of it as writing the opposite of each element of matrix K. Okay, let's do 3n plus 2m. Okay, so here comes 3n. And of course, we will multiply each element by 3. So that's going to give us 6, 18, negative 93, 66, 30, and 0. So that is 3n. Now let's do 2m. So we will simply multiply each element by 2. So that will give us negative 10, 18, 4, 22, negative 1, and 3. So we can get the final result by adding these two matrices. So again, if I simply add the corresponding elements, I'm going to get negative 4, 36, negative 89, 88, 28, and 6. I made some mistakes right here. Don't know what I was thinking. But obviously, 2 times negative 1, that's negative 2. And 2 times 3 is 6. So, yeah, I don't know what I was thinking there. All right, in this problem, we have to solve for variables. But we can rest assured that the corresponding elements must be equal. So we can make 3 tiny little equations by setting this element equal to its corresponding element. So 12z must equal 3. So if I were to solve this guy, I would divide both sides by 12. So that's going to give me z is equal to 1/4. All right, similarly, if I want to find x, I can do it by setting these corresponding elements equal to each other. So negative 15 must equal x plus 4. And if I want to solve this, I would simply subtract 4 from both sides. So that tells me that x is equal to negative 19. Okay, and finally, if I want to find the value of y, I could set these corresponding elements equal to each other, as they must be. So 18 must equal 6y. To get y by itself, of course, I would divide both sides by 6, which tells me that y is equal to 3. Okay, so we have solved for x, y, and z. If I do the same thing for this problem, it gets a little trickier. Please understand that this expression 2x plus 3y, this is a single element. This is a column matrix with only two elements, 2x and 2x plus 3y. So I can make new equations by setting each of the corresponding elements equal to each other. So one equation I can get is 2x equals y. Another equation I can get is 2x plus 3y is equal to 12. So what I have is a system of equations with two variables. I have two equations and two unknowns. I would like to do substitution since I already have one variable by itself. So y is equal to 2x. So I should be able to substitute this in for y in the other equation. So that'll give me 2x plus 3 times 2x is equal to 12. So 2x plus 6x is equal to 12. So 8x is equal to 12. Dividing both sides by 8, I get x is equal to, both of these are divisible by 4, so that's going to give me 3 halves. So x is equal to 3 halves. Okay, now I can substitute that back in for x. So that's going to give me 2 times 3 halves is equal to y. Well, this is like 2 over 1. So I could multiply 2 times 3 and get 6. So I'd have 6 over 2, which is 3. Or I can just notice that these 2's will cancel each other out. Either way, y is equal to 3. So I get x is equal to 3 halves, and y is equal to 3. Okay, here again, I can make little equations by setting the corresponding elements equal to each other. So 2x is equal to 5, and dividing both sides by 2, that's going to give me x is equal to 5 halves. Okay, if I want to find y, I can set these equal to each other. So that's going to give me 3 is equal to 3y. If I divide both sides by 3, I get y is equal to 1. And one more time, I can set these corresponding elements equal to each other. So 3z is equal to 9. And then I can divide both sides by 3. So that'll give me z is equal to 3. All right, let's do one more problem. This time I have the sum of two matrices, which equal a third matrix. So if I want to find an equation that I can set up, I'm going to do this plus this and set it equal to this. That's going to give me an equation. So that gives me the equation x plus negative 15, or simply x minus 15, is equal to 3y. So that is one equation. Okay, now I can get another equation using these corresponding elements here, here, and here. So x plus y should equal negative 1. So x plus y should equal negative 1. So again, I have this system of equations that I can solve, and I think I will stick with substitution. So one thing I could do is get x by itself. All right, I could have gotten x or y by itself over here, and it would have been just as easy. But I could get this x by itself if I add 15 to both sides. So that will give me x is equal to 3y plus 15. So now that I know that x is equal to 3y plus 15, I should be able to take it and substitute it into the other equation. So that's going to give me 3y plus 15. Okay, that's x. And then I'll have the rest of the equation. So plus y is equal to negative 1. Now there's nothing in front of these parentheses, so I can really just ignore the parentheses and combine like terms. So I've got 3y plus y, so that'll be 4y plus 15 is equal to negative 1. Subtracting 15 from both sides, I get 4y equals negative 16. All right, next I would divide both sides by 4. And that's going to give me y equals negative 4. All right, so that is my first variable, y equals negative 4. I can take this and substitute it back into the first equation. To find x. So that will give me x is equal to 3 times negative 4 plus 15. So that will give me x is equal to negative 12 plus 15. So that tells me that x is equal to 3. So x equals 3 and y equals negative 4.